So with that, I think we're going to go ahead and get started here. Welcome. My name is Mike Raftery. That's my picture. Although I shaved my beard today, so I guess I look a little different than that. Just a quick introduction of who we are and what we do. Again, we've been doing SCM Connections. We're a system integrator working with SAP, mostly in the IBP space, although we've done supply optimization for about 15 or 16 years between previous generation tools like APO and now with IBP. So this is a topic that we are extremely familiar with. We love working with. It's very powerful and something that's actually driven quite a bit of value to our customers over the past couple of years. So my experience has been in supply chain planning solutions and specifically on supply optimization. I've been working in this space in consumer products and healthcare since the beginning of my career, and something that I would say the number one thing that we've seen, and me personally, I've seen drive value for our clients is optimization. So we're excited to be sharing it with you today. I thought I'll let Nikki introduce herself. She's going to do a lot of the heavy lifting here as well.
Hi, this is Nikki. I am a recent graduate from Northwestern in industrial engineering, and at my time at SCM Connections, I've been focusing on supply optimization in the healthcare and consumer products industries. So I'm really excited to show you guys what all the optimizer can do here.
Yeah, great. All right, so we're going to keep it moving today. Again, please ask questions along the way. We don't pretend to have all the answers, but if we have the answers, we will absolutely share it with you. We're going to go through a couple of different topics. One is just an introduction to the optimizer and what it is and who we are. A couple highlights about IBP, but then we're going to get right into the weeds of optimization and show you multiple scenarios side by side that, especially in consumer products, are fairly relevant in terms of what optimizer can solve that a standard solution or heuristic probably can't get to. So with that, we'll go ahead and jump right in. So just quickly about us, like I mentioned before, we are a leading North American systems integrator for IBP, specializing in supply and inventory optimization as well as demand planning. And we're going to be highlighting the supply chain optimization today. It's one of our favorite topics because, like I said, it adds a lot of value to it. We've been working in APO since 2001 as SAP partner for about 5 years, and recently have gotten the credentials of recognized expert in the supply chain management space, which is something that we're very proud of, specifically because the majority of that credential from SAP is from client references. So our clients are happy with us. They told SAP they were happy with us, and we were the first ones in the US to get that designation in the supply chain management space. So we're awfully proud of that, and something we like to highlight because it's a customer accolade. So what we've done today, this is sort of the overview of what IBP is, or Integrated Business Planning, and it's made up of a few different modules. So we're going to show today the ones in red. So we're not going to get too much into control tower. We're definitely not going to get too much into demand or inventory. But what we are going to do is look at what you would call the S&OP, so sales and operations planning, as well as the supply optimizer side of response and supply. So response and supply is made up of detail order planning or order series data, as well as time series data for optimization to support supply chain planning. And that's what we're going to show today. So the two of them work well together, and they provide for a platform that allows you to optimize your network and your capacity management, which is what we're going to walk through today. So quickly, for those that haven't seen IBP before, there's a couple advantages that are going to allow the functionality that we're demonstrating today. The first is the cloud, and as you'll see Nikki's demo, it's going to work with Excel, but all the data that she has is going to be resident in the cloud-hosted server. So none of this is, it allows for probably more robust hardware and more up-to-date hardware than you would be able to get on your own. It also uses an end-to-end data model, so you'll be able to see things like revenue and profitability in her scenarios because it has customer pricing, supply planning, costs of production, all of that baked into one model. For those that are APO users, it doesn't have multiple planning areas that go back and forth. You'll see the modern user experience. You'll actually see Excel, you'll see graphs, you'll see things that even for those of you that have never seen IBP before, it'll be intuitive for you to understand exactly what we're doing and why we're doing it. the planning algorithm, so you'll be able to see the optimization. This is a fairly robust algorithm that uses linear programming to maximize constraints and minimize costs in your supply chain. And it does that with a series of constraints that are modeled, everything from capacity to storage to aggregate constraints. And we're going to focus mostly on capacity today. And then simulations. This is the big one. So Nikki is going to show you side by side each and every different combination for you to review what the differences are for each simulation. So all those together are some pretty powerful tools, and they're things that we're going to end up showing today live. So what you're going to notice, the big one though, is the fact that this becomes a conduit for the conversation. And we want to show today is how these things can actually, specifically an optimizer, can take complex scenarios and make it digestible for everybody. So we're going to show very complex simulations. We're going to show it in a way that you can relate to solve business problems. So for example, what's more profitable, what's less profitable, how is it working, and what are my constraints? So that's all going to show side by side in a way that's really easy to work with. So it's going to show the integration between finance and supply chain, and that's something that should not be taken lightly because it moves your supply chain from a level of Gartner Maturity 2 to 3, where you're not just saying, can we do this, but should we do it? So what you're looking at are things like, should we move this source from A to B? Is it more or less profitable? Which is a whole different conversation than just does it fit? And those two things combined allow you to make better decisions overall. The fact that you can simulate these in real time, as we'll show you, also means that the decision-making process can be a lot faster. You're not waiting for reporting extracts, you're not waiting for different VLOOKUPs to come together. All this is happening in real time. So your supply chain planning team will be able to work with this side by side, getting not just can it happen, but should it happen. And then integration is really built because of this single planning area. If you have customers and vendors, plants, and transportation all in one data model, what that allows you to do, it allows you to take profitability. And the green box on the left, customer, was not available in the supply planning optimizer of APO. Instead, what it would do is just have demand at a distribution center. When you expand your supply chain from customer to vendor, it allows you to bring in the cost elements. So different pricing conditions on different customers are known, different costs of different vendors are known, and putting it all into one simulation means that you can actually evaluate, is this better or worse for the business, not just can or should it happen, and show that impact side by side. This what-if planning allows you to do it. Versions are one area of what-if planning, which allows you to simulate things like new plants, new materials, new master data. However, we're going to work with scenarios today, and the scenarios are very quick-hitting, very agile planning objects that you can say, can we do this, should we do that, really quickly create, manage, and compare these scenarios side by side. So that's going to be pretty nice. Next is going to be the planning process. So we're going to work through some of this, mostly constrained supplies in the production capacity. And so this entire flow across the network, we're going to focus on alerts and capacity. Basically, where do you have issues in your network that might be preventing you from serving your customers efficiently and profitably? So you want to take this one?
Yeah, so the optimizer is a pretty powerful tool in IBP. It takes all your different requirements that you have as a business and kind of produces a constrained, feasible supply plan. So based on your business needs, you can decide to have the optimizer maximize profit or delivery. You can set different penalty costs that will impact the outcome of the optimizer to say, satisfy all your demand or carry safety stock. The optimizer will run through all of these possible solutions to find the best way to balance your supply and demand with the least costs. So the supply planning heuristic in IBP, it actually produces an unconstrained plan. So sometimes the result indicates over 100% capacity usage. So when this happens, the planner would go in and manually adjust the plan to ultimately arrive at something more feasible. But with the optimizer, the tool itself will calculate all of these different plans and result in a minimum cost way to meet those requirements while also staying within capacity. So the planner can then spend more time on what-if planning.
So for those that haven't seen it very much before, if there's anybody that needs a little bit more background on the optimizer, just click the little hand to raise your hand. But if you're familiar with it, we can keep moving. What we're going to show mostly is the optimizer, and a heuristic is a fancy word that might not mean that much if you haven't played with it very much, but it's basically just a supply-demand match. So the best way to describe it would be an infinite capacity plan. So you're going to show the requirements show you what you need, not what you can provide. Contrast that with the optimizer, which gives you what you can provide by layering in those constraints. So what I always use in some of the training classes I do is to say the heuristic will give you the problem, the optimizer will hand you a solution. And that's really how it would work out in real life as you're planning it.
Yeah, and it kind of feeds into the way the heuristic actually solves the problem. So going off of what Mike was saying, the heuristic will solve in silos. So it'll run through all of your customer demand, and then based on that, move to your DCs, and based on that, move to your plants. So it kind of solves one level at a time. And you can see that in this network diagram. But if you look at the way the optimizer works, it kind of takes all of your solutions for your entire network at once, and it uses linear programming to do so. So it considers all of your planning problem-related factors at one time. And that's one of the biggest benefits of the optimizer, is that it takes some of that manual leveling away from the user and kind of produces you with an already feasible plan that you can adjust as you go on.
Exactly. Nikki and I were talking about this a little earlier today too, and it's just kind of a way about how human beings think. Humans tend to think very linearly, like I'm going to move this here, there's an open space, I'm going to move it there. And it's very much, step one, step two, step three. That's why instructions are written that way. An optimizer will look at everything all at once, all at the same time. And it's just a different way of computing the problem. And if you think about how, it's basically starting from scratch every single time, and humans just tend not to do that. One, because just the way we think, and two, because of time and space constraints, you can't possibly look through every iteration. So that's a key element, and it's really what unlocks the ability for the algorithm to do more than any planner could possibly do on their own.
Yeah, so let's move towards the demo. So in today's demo, we'll really walk you through the supply optimizer and its different features within IBP. So we're going to show you two different scenarios and really highlight the tool's what-if planning capabilities. So let's jump into the system.
Yep. So if anybody hasn't seen it, this is IBP.
Yeah, so
you probably used something very similar to it at least for 4 hours already today.
Oh yeah, IBP they do have a web interface, but the Excel interface it's really easy to use, and it is your classic Excel with this fancy IBP ribbon up at the top, and that hosts all of your different options, that different operators or anything else you might want to do within the tool. So I have a planning view open over here, which is basically just a workbook that planners can use, and there's this option to save your favorites. So I just kind of pulled one of my favorite views out, and we'll just walk through this one.
So as Nikki's setting this up, one thing to point out for those that have not seen IBP before is one thing I mentioned in the benefits of IBP, which is the usability and the I forget what the term was, but basically the user interface being so robust. Basically, if for those that are used to an ECC or an EPO world, you're used to these menu trees, you're used to /n commands, you're used to typing in all these sort of obscure transaction codes. Now it's all in front of you. As Nikki mentioned, the toolbar is intuitive, it's graphical. You're using Excel, which, I mean, you can't even work in today's business world without being somewhat of an Excel expert. So the fact that this becomes your planning engine, your planning front end, means that users pick this up much faster than they ever could in the past.
Yeah, so what I have open here is the optimizer planning view that we'll work with, and You can see at the bottom, I have all these different tabs open here. They're just different views that we can look at. And they cover all different parts of the supply chain. So IBP is a process-focused tool. So I'm able to model that process in the different tabs that we have here. So if we start at the demand tab, we can see that you have your customers here, and you have different products. So the product customer view, where you can see your demand that the customers have for that product, and then you can see your total customer receipts. So I've actually already run the heuristic here, and the heuristic, like we mentioned before, it assumes infinite capacity. So the real goal here is to kind of match your supply and demand. So as you go into these, like maybe 2 weeks in, you can see that my total customer receipts, or what I'm supplying to the customer, it's exactly the same as my demand. So we don't really have any shortfall here, and that means the heuristic did its job. And so you can see even in the chart here that the two are equal.
And no matter what, the heuristic says, here's what you need to work with. It may or may not fit within reality, but when you run a heuristic, that becomes now your problem to figure out. It just tells you basically the net requirements to meet the demands. And so if you are in a world that is not capacity constrained, it's not seasonal, it's pretty much you have the capacity to do whatever you want, and you're just filtering requirements through. A distribution business is another good example. This might be enough, right? This might just be enough that you don't need, you don't have a lot of complex scenarios to work with, in which case a heuristic might do it for you. That's not what we're here for, right?
Right. So if we come to the capacity tab, we can see in this scenario, in this baseline, we are looking at 229, 232% capacity utilization. And we all know that that's not possible to go over 100. So this is where, if you were using the heuristic, the user would come in and do manual capacity leveling. But what we really want to show here is the function of the optimizer. So what I'm going to do is I'm going to come up to editing my planning view. I'm going to switch the scenario that I'm showing and show you the seasonal demand scenario. So let me just set up the scene a little bit while everything is loading. What we're actually working with, the supply network we're looking at, is hot dogs, sausages, and bratwurst. So you might know that for these three items, the demand for these is a lot higher in summer, maybe during baseball season, during 4th of July. In fact, on 4th of July, that's when the highest number of hot dogs are consumed. So we've set up this supply network to show an increased demand during May through September, about Memorial Day to Labor Day.
So what we had one question on the webcast, Nikki, which was, can you set these resources up to be infinite as well as capacity constrained at the resource level? And the answer is yes, you can. So we have set up a fairly straightforward network of constrained resources. But if you have resources that you want to project as infinite, such as like labor or something, then you can absolutely do that. That's not what we have today, but it is possible within the realm of the IBP application.
So I'll have to apologize. My Excel is taking a little bit long to run today, but like Mike mentioned earlier, it is hosted on the cloud, so sometimes these kind of things do happen.
The guest network is usually the bane of the performance. So what we're looking at here, though, is going to be the scenarios, and not to gloss over that, but you saw Nikki switch from scenario to scenario. It's the same data set. It's just that she's run two different solutions on it. And you can see that extra column there in column J now has seasonal demand listed. So that's the indicator to the planners that, oh, this is not the live data, using air quotes, live data. This is the data that I'm playing with. This is my scenario. Nobody has access to this besides Nikki at the moment. And so if her boss has come in and said, how do I, how are we looking this year if demand goes up 20%, or what's this season look like, or if I'm gonna run an optimizer, this is how she would work in it in sort of a what if scenario without actually changing the real live plan.
Yeah, so now that it's loaded, what we can look at the customer demand tab, And because it's the optimizer, it's not necessarily going to match up our supply and demand. So you can see here we have a couple instances where the total customer receipts are actually less than the consensus demand. So that means we do have demand shortfall. And this happens a couple times, as you can see here. We just don't meet all of the demand. So what we can do is come to the capacity tab, and we can see that the capacity utilization is 100 in those weeks that we were looking at some demand shortfall.
Right. So there's 3 resources here available, all of which are 100% utilized. So if you go back, can you go back to your diagram real quick?
Mm-hmm.
So if we go back to our diagram, you have your 3 plants, 1010, 1310, and 1710, and they can supply any of the distribution centers and any of the customers across the country. Now we set up for 1710 to be the most expensive production facility, but everybody can make everything. And if you go back to your view, you can see that in those weeks that Nikki was showing, there is no more capacity, right? And even when there is capacity, it is filling up the cheaper resources first. So as a heuristic, we'll evenly split your your capacity requirements by ratios or by quotas. The optimizer will do a cost justification, and that's what it's doing here, right?
Right. So if something is too expensive to produce and it results in a higher cost, that's not the route the optimizer is going to advise you to go on. So we can also
I went ahead to register to see if it would let me, and had to look at it. A little late, but 5 minutes.
Okay, sorry. You were muted there for a second. Why don't you try again?
Oh, there you go. So right now what we're going to look at is the safety stock tab. And one of the nice things about IBP is that, I was working on the inventory tab and there were just so many different metrics there. And I knew I wanted a cleaner view, so I easily went up to the edit view, made a new one, and just picked out 2 different metrics, or key figures as they're called in IBP, to look at here. And so that's what I want to show you here, is that for the different product family and location type, we can compare the projected stock with the final safety stock recommendation. So our tool is telling us, or maybe it's the data that you've uploaded, that you want 4,032 in safety stock, and what the optimizer is telling you is that your projected stock for this product at this location, it's going to be less. So that's where you can come in as a planner and make adjustments, see why this may be happening, and focus more on the root cause analysis rather than trying to get the most cost-effective solution. So one other thing to point out here is that we're looking at aggregated data. So if you remember on the other tab, we were looking by product, by customer, but right now we're looking at product family. So I've taken all those different types of hot dogs and I've categorized them all into a hot dog family. And then over here, instead of looking at my actual locations, I can just group them all into DC plant. What's nice here is that we only have a few of each. But in a bigger network, this might be really helpful to consolidate it all. So something else that we can look at is the DC to customer tab. And this is just one of the arcs that you have in your network. When you're looking at the customer to DC, this view shows you how much the DC can supply to the customer. So as you can see, while it's loading, this is still accurate. We still have these 3 different DCs, Boston, Detroit, and Seattle. And they supply, it's a 1-to-1. They supply 3 different customer regions. So Boston will supply the East customer region, Detroit the Midwest, and the Seattle DC will supply the West. So we're looking at the customer supply which in reality should be equal to the customer receipts at the customer. So we can see how it's all split up here. And you can go way into the future, but one thing you'll notice is our overall kind of seasonal demand peak is towards week 26, 27, which is right around July 4th.
So in this case, it's giving you the actual seasonal demand. It's pre-building in advance of that demand, and it's giving you the best possible option because you don't build capacity to be 100% all the time. Right? It's not efficient. So in this case, you can pre-build that and still meet everybody's requested demands throughout the year.
Yeah, exactly. So we just looked at DC to customer, but what about plant to DC? And that's what the transportation tab is really helpful for. So you can see the transport receipts from your plant to your DC. And where, if you remember our network, which I'll just show you again real quick, we have 3 different plants, like Mike was mentioning earlier, and 3 different DCs, and all of the plants can supply to all of the DCs. So we also, like Mike mentioned, set 1710 to be one of the most expensive ones. So we can see in the planning view how that effect has taken place. Another thing to consider, and we can see this on the capacity tab if we jump back, but 1710 also has the most capacity supply. So even though it's the most expensive, sometimes it will supply the most, highlighted in this blue color here, because it has the most capacity. And this is where the optimizer is really key in making that trade-off.
Right, so it's balancing not just one cost or the other, even if 1710 is the most expensive, which it is. Sometimes it's basically balancing out the fact of, should I build on more inventory on a cheaper resource, or should I carry less inventory on average and use a more expensive resource? And so everybody, when you know your network and you know your plans, everybody kind of knows, oh, this is the expensive plant, or this is the expensive production line because it's older or it's less efficient or whatever. If you put those costs in, which we have, as a production cost for the optimizer, it'll go ahead and balance that out automatically. So you can set things like a minimum floor, you could set things like a max, the maximum is obvious, but that is the part that humans can't really do. So when things change, to go back and say, well, where is that tipping point? I mean, I guess in theory you could do it, given enough time and and enough math, but this is doing it for you naturally. And that's what this is meant to show, is how the production and the capacity will flex and give you the least cost solution no matter what. So even if it's a bad solution, it's still the cheapest bad solution possible.
Right, exactly. And I just want to highlight something really quick before we jump to the finance tab. If we look at our capacity tab, you can see that typically 1710 is not at 100% utilization, typically, so maybe in the first week, yes, because it wants to play, it wants to catch up or plan in advance rather, and of course it gets closer and closer to 1, but overall it's not at 1.
And if you look at the most capacity, it's in the summer, right?
Mm-hmm.
In the summer is where that demand is. So it's trying to balance out when it's going to make it versus the timing.
Exactly. So let's take a quick look at our finance tab, where we can see some of the overall costs resulting from this optimizer run. And we're going to look at total production value, we're going to look at average projected stock value, and we'll look at your total demand revenue of what you can actually supply. So it's loading real quick, but just to give you a little heads up, once we look at this, we're going to run another scenario where we look at some downtime in one of our plants, and we'll compare those costs to these. So we'll write these down so you guys don't have to memorize these, but right now we're looking at a total production value of 93 million, average stock of 225,000, and a constrained demand revenue of 167 million.
So going back to some of the strengths of IBP, what Nikki's going to do now is create a scenario on the fly. So she gets a phone call and says, which one are you going to take down? Which line are you going to take down?
1710.
So she's going to get a call, and that 1710 production line broke. And they need to do some capital maintenance, or there's some emergency maintenance needed at a certain point in time. And that's what she's going to do right now. So you can see on the fly, this is a user. This is something a user would do. There you go. And you'll see the seasonal demand will now have a secondary scenario. So seasonal demand is just sort of a generic one. And then you can see that downtime on 1710 is created right away. Now this is something, like I said, a user can do. That's extremely powerful, because if somebody comes in and says, hey, what does this look like, or what's the impact? A planner like Nikki could go ahead and do that on the fly. This is not something that takes a week or a change request or IT to help with. This is something that now with the IBP platform, you've given power back to the users, and they can go ahead and control it for themselves. So in this case, Nikki's boss calls up and said 1710 needs to go down for whatever, 4 weeks. I need to be in a meeting in an hour. Tell me, how bad is it going to be? So if you come in here, you'll see that scenario tab will switch, right?
Yeah, so we'll be able to see the two scenarios side by side. We'll see the seasonal demand scenario that we've been working with, modeling our high demand in the summer months. And then we'll see below that the downtime on 1710. And what I'll go ahead and do is come in to weeks 19 through 22, which is May. That's right around when the peak season starts. It's around Memorial Day. And I'm going to come in and cut off 1710's capacity supply.
And again, by doing it here, the benefit is that you can play with the different variables without actually impacting the real live data. So in this case now, you see both of those scenarios side by side. That's another really important feature of this thing, that you can see them next to each other. You don't have to flip back and forth. You don't have to create a report on your own. You don't have to go ahead and generate offline spreadsheets or VLOOKUPs to do comparisons. You're right in here looking at that side by side. And those green cells that are highlighted there is where the downtime maintenance is, right?
Yeah, exactly. The nice thing about IBP is, yes, it is very user-friendly, but it doesn't let you make mistakes very easily. So it has automatically highlighted my edits in neon green, and I can go up here and hit Save Data, and it will ask me, are you sure? And then I can write a reason why. But yes, I've modeled this downtime by entering zeros in for the entire month of May.
Nobody needs to see this but you, right? This is your what if plan that you can bring back. And when you're doing these, one of the things that is really nice to see is if you like the plans, let's say there's 3 different options. You can create all these scenarios all day and then merge it back into the mainline plan. And there's a button there on that scenario, manage scenarios screen. I don't know if you caught it or not when it was there. But there was a button on that manage scenarios screen which allowed you to merge the scenario back to baseline. So what that does is say, if you like this scenario, we're going to go ahead and adopt it and bring it back into the main plan. So you don't have to redo work. You don't have to worry about extra effort or miscommunication or mistyping any of the information when you're doing it. It's actually going to merge it back in for you and create those deltas. So it's always consistent, which is nice. If you bring into a meeting, I like options A, B, and C, and your boss says, I want option D, it's easy enough to do. And you can see there, now we've got those 2 scenarios side by side, queued up and ready to run an optimizer.
Yeah, so that's exactly what we're going to do. We're going to run the optimizer, and it's a fancy button here under Advanced Run. It's one of these operators here. And you can set the settings for your different optimizer profiles based on your different penalty costs that your business might have. But what I'm going to do is select the supply optimizer, constrained, downtime scenario, and I'm going to use my...
And just to point out before you click next, those scenarios all show up individually. So you're running it only on the data that you're working with, not on the entire plan.
Exactly, and that's what I did earlier is I ran the heuristic on our baseline, and I ran the optimizer on the seasonal demand, so we were able to compare the two. So I'm going to go ahead and run this. And then we can easily just check the status, and you'll see that it doesn't take very long because we're not working with a lot of data. But you can see I've
run a
lot of these today.
So these logs are going to be just like the logs that you see for the solver. It's going to show you statistics about the solve. Again, users in general won't really see these. It's rare that they would fail. Even in some of the larger projects I've worked with, you know, the solvers would take 40, 45 minutes, but this one's definitely not that complex. But it's rare that it would actually fail, and some of the people that are used to linear optimization tools will be familiar with those statistics in here. You can see here it's finished, and we'll go ahead and see the results.
So we'll stay on our capacity tab since that's what we just modified here. We'll go ahead and compare how the capacity is being used and the utilization rates of the different plants and the resources, rather. So you'll remember we cut capacity supply for 1710 in the month of May, which is weeks 19 through 22. So what we should expect to see is some of that unused capacity from 1710 in the earlier weeks being used up now. Because you'll remember that 1010 and 1310, those were almost always at 100% capacity usage. So we're going to expect that 1710 will just shift capacity usage up earlier.
And what IBP will do, because it's integrated, and the integrated means it's integrated. So what we'll walk through is not just, okay, there's extra production going to 1710, but all of the secondary effects of what that means. So for example, how does my transportation change? Do I need to get carriers on transportation lanes that didn't exist before? Or are there components that I need to move around that weren't required at certain locations before? So if you look here, I mean, you can see right away, right? There's your impact.
Yeah, so you'll remember that in our beginning.
I like those two rows. That's pretty stark right there, 15 and 16. Yeah, look right there.
Yeah, you'll remember that in the beginning when we were looking at the other scenario, the usage on 1710 was pretty low, but right now we're looking at a pretty significant increase from 3,000 to 5,000, then the next week immediately to 10,000 for a couple of weeks there. And then you'll see all of the downtime right here. There's just no usage.
And so what that tells you right away is, what is that going to do to my plant? Now, it's not going to do much to 1010 or 1310, but to 1710 now you got to say, we might need an extra shift, or we might need to work a weekend or whatever because of the capacity differences that you have. Again, we just kind of have generic units, but it could be anything from hours to shifts to pieces. It's kind of however you decide to set up your supply chain.
So one nifty thing about IBP here is that, yes, I do have this chart up here, but I can easily change that on the fly. So this chart really doesn't serve the same purpose now that I've added a second scenario. So what I could do is clear those series and add in my two scenarios.
Yeah, go ahead and do that.
But we'll go ahead and look at the production tab. So yeah, again, we'll be able to see this side by side. So once you select in your view to see the two scenarios, it'll appear in every single tab. And then if you wanted to, you can create different workbooks to support different functions or different views. Maybe you want one workbook solely for one scenario, for example. And there's a lot of flexibility with how you can set this up.
And that's a good point in terms of the process. So IBP is pretty flexible as a platform in that you can design this however you want. I created this one before, and basically I just said I kind of want to walk left to right from demand to production, and then I want to see the financial results, and on the far right is the input costs. Some people like having multiple workbooks, so one for each function. Just kind of depends on what you're looking for.
Yeah, so what we can see here is some of the same results, especially with what Mike was mentioning earlier, is that we've just seen some of this production shift earlier. And you can see like the stark difference in our two scenarios here. If we just look at these two rows, this is pretty different.
And one more to highlight, Nikki, go to rows 11 and 12 there. So this is something that I think is a key part of the optimizer that can't really be fully understood until you see it. So we changed 1710, and you saw 1710 get more production. And so this is the difference between humans solving an equation and optimizers, I guess, right? So where a human would just kind of move the 1710 production, the optimizer goes back to square one and resolves that problem. And if you look at rows 11 and 12, you can see that's a resource that was 100% in the beginning, and it's 100% now. However, it's a different 100%. So the product 300 is not there in the downtime scenario, but it is there in the seasonal demand scenario. And that's key because when you're reviewing the impacts of this, so Nikki's run this, her boss has said, what are the impacts? You can't just focus only on the products at hand or the line at hand. You get to see the ripple effects throughout that entire supply chain, even on the resources that aren't always there or aren't apparent, which is really interesting, not just from a production point of view, but also a transportation point of view. And that's the benefit of having a cost-based optimizer. It'll go back to the beginning, it'll resolve the entire problem for the least amount of cost based on all of it. And I mentioned before, that's the difference between just humans and how we think and how an optimizer will work. It goes back to that all-in solve that Nikki showed, where it's evaluating all elements of your supply chain all at once, and it's looking for the least possible cost across the entire thing. Transportation one is, I always think, is an interesting one because it's not just showing production, it's showing where volume is moving. So for example, you might not have things like carriers on a lane, or you might not have enough trucks on a lane. Those are type of elements that you'll need to do to support this plan. And without this sort of data out there, you wouldn't really understand the impacts. And so while, for example, it might be feasible to support this adjusted plan on 1710, it might not be feasible to support it from a transportation point of view. All right, so if you look at 1310, again, 1310 didn't change at all, right? So if you highlight rows 7 and 8 real quick, okay, you're seeing, and scroll to right just a little bit. There you go. So you're seeing a dramatically different supply plan throughout your network with an unrelated plan. And so when you're looking at, can this happen, right? Can we support this? Can this plan be feasible? You need to look at it across the entire supply chain. And that's one of the benefits of having an optimizer, is that it allows you to do just that. And in this case, you're looking at shipping from 1310 into location 1720 changes dramatically in that time frame. If you're looking at the 4 weeks of the 16th to the 20th, you went from whatever that is, if you want to highlight those, like, you know, 5,200 to about 3,200, right? 3,500. Now that's not that much, but we don't have that big of a model. Now, you know, if you extrapolate that out across the entire supply chain, you could have some significant impacts in how you flow. Same thing for inventory. Which products are you keeping where? Where are you going to keep those products? So that's another element to say, yeah, we can support our customers, but it may or may not be cost feasible to do so, or practically feasible to do so if you have constraints on such, for example, storage or transportation.
Yeah. And we've been talking a lot about these costs, and I think one really cool thing about the optimizer is the ability to model hard constraints, pseudo-hard constraints, and soft constraints. And so you can set different penalty costs on different, metrics. And basically, you can have the optimizer say that, okay, these different constraints have to be met. These, I would really like them to be met, but if it comes down to it, it's okay not to. And some that are just nice to haves. So those are the soft constraints.
Mm-hmm. Yeah, it's really interesting, and you can tell we kind of get into it in terms of what it can do, but they end up almost having personalities onto themselves. For example, soft constraints could be cost penalties. Like, I really don't want to use this, but I can if it's really expensive. And so you would call soft constraints things like transportation methods that are maybe preferable but not required. Or, for example, we really would prefer not to carry this much inventory, but if we have to, if it's the difference between shorting a customer or not, then you need to do it. Right? That would be a soft constraint. Hard constraints would be things like storage in a building, right? There's a finite amount of space and you can't really exceed it.
Exactly. So one thing we just wanted to show you guys on the demand tab is that we've set up, this downtime, and we've seen how it affects different parts of our supply chain, whether it's the production or inventory, even our transportation. But when it comes down to it, is it affecting demand? And I think that's something that's really important to a lot of businesses, is how your delivery is to your customers. And you can see that it's pretty much the same as our seasonal demand scenario. We don't really see too much shift. Actually, none at all, yeah. And that is because we're not going over capacity, we're just shifting which plant is supplying. So we're not really affecting any of our customers.
Yep.
So
it moves from, can we support this? Absolutely, we can support it. We can support it, our customers won't realize any impact. The secondary question then becomes, at what cost, right? And that's what you were going to.
Yeah, exactly. And that's where we can take a look at the finance cost and see, okay, if you'll remember, we had a total production value of 93 million. Our average projected stock value was 225 million. And our constrained demand revenue, or the revenue from sales was 167 million. So as this loads, you can see how we can compare the two costs. And think about it this way, if this scenario with the downtime was the most cost effective, the optimizer would have split that out in the first place. But we've introduced additional constraints in having zero capacity. So the cost should probably go up, but it's still going to be a feasible plan and get the job done, meet our demand. So you can see how we've shifted here.
Oh, actually went down somehow.
Yeah, that worked out well.
But what happened? Your average stock value went up.
Yeah, right? Exactly. So we're seeing $53,000 more of an increase. On average, right, of an increase on our stock value. Even though we did see a little bit of a reduction in production, and our constrained demand revenue is the same. And you can tie that back to your demand tab, where we saw that how much we're supplying to the customer did not change.
Right. So again, can you do this? Yes. Does it make sense, or what's the cost going to be? Well, our production costs, in this case, again, we're doing this on the fly, but the production value went down, but the overall inventory carrying cost went up. Those are different elements to consider when you do it. And they might say, like, great, as long as we can meet it, fine. We are okay carrying the extra capital to make it work. Others might say, you know what, we don't have that sort of capital to carry week over week, or we can't really handle that as much, so we're not going to do that.
That's where IBP is really nice, because you can take these three scenarios that we've just looked at, the heuristic run, our seasonal demand, and our downtime, take this back as a planner, take it back to your boss, have the business decide, okay, what are our goals here, what are our priorities, and then move from there. But it's pretty simple to view these scenarios side by side.
Mm-hmm. And again, we did this a fairly simple scenario, but in about a half an hour, right?
Yeah.
Set up a change, modeled it, and provided it back to answer a business question. One thing just to highlight with IBP in general is how well it does answering business questions, because everybody hopefully can follow this, right? You were able to see the cost, you're able to see the capacity change on a network you're not even really that familiar with. And this is where, to me, it all kind of comes home, right? You have your Excel front end that's easy to interpret. You have your financial integration, which makes you easy to evaluate. And you have scenarios, which makes it easy to model. You can do this stuff without going offline, without going and doing VLOOKUPs, without doing offline Excel spreadsheets, and still provide a high quality integrated answer using a very advanced tool. And we kind of made it simple, hopefully, for everybody, but this goes out to simulate entire networks in the same way that we've kind of mocked it up here. So with that, I think that was, again, the demo that we had. We've got a couple minutes left if there are any questions. Again, you know, this is a very simplified demo. If anybody wants to see this or evaluate how it works for you or your supply chain, our contact information is here. You can look us up online. I think I sent everybody an email earlier, but please look for us, and we're happy to answer any questions now or that you might have in the future. I'll wait a minute, but I think. So one question is, can you run chart comparisons of scenarios side by side? So you want to show that real quick with the two scenarios? The answer is yes. Yeah, in Excel. So let's go ahead and give it a shot. I think we're getting into a weird display element in our. The question is, can you run it side by side? Let's see if we can pull it up here. I think because we're projecting, we're getting a bit of an odd Excel behavior. But the answer is yes, you can run them side by side. All you do is create these two scenarios and make them a series. I don't know why this one isn't working. I think we have because we're projecting through a webinar, we're getting a weird little bug in the display. But yeah, it can get side by side. Just like right here, we have 3 series. You could easily put capacity utilization for the 2 scenarios next to each other without any issue.
Yeah, something else.
Usually without any issue.
Something else you can do is use the web view, which is, again, pretty user-friendly, and also create different analytics, maybe create a supply network, or create different dashboards, compiling, you know, different charts and network diagrams. And you can do the same thing on the web and compare your 2 scenarios.
We had a couple other questions come in. One is, can you do a discrete solve and a linear solve afterwards? So basically, can you set up a discrete horizon in your optimizer profile? And the answer is yes, you can do that. It's a setting in the profile. We didn't get into optimizer profiles here, but that's a setting on the website that you will do to configure your optimization profiles. When Nikki ran it, you saw there were 4 options. You would just set up different options to do that. Any other questions or hands raised that we can answer today before we go ahead and sign off? Going once, twice. All right. Well, thank you everybody for attending and giving us some of your busy schedule. We really do appreciate it. Like I said, this is Mike Raftery from SCM Connections. You can find me online on LinkedIn. Find me on Twitter at Mike at SCM or Mike SCMC. And my email is mike.raftery, R-A-F-T-E-R-Y at SCM Connections. And
this is Nikki Jane. You can email me at njain@scmconnections.com. Find me on LinkedIn. It was great walking through this today.
Yeah, thanks everybody for your time, and we look forward to speaking with you all later. Enjoy the rest of your Tuesday.